So as I mentioned before, I posted the follow along note taking guide in Edsby for your benefit. You can either have it open now and kind of fill it out as we go, or if you find it more beneficial to just sort of sit tight and listen and you want to fill it in later, both options are completely acceptable. Sometimes people will ask me, Mr. Seidenberg, are you going to collect the note-taking guide to make sure that we did it? No, I'm not. That is for your benefit. I've mentioned it before. One of the big differences between elementary and high school, in elementary school, they collect almost everything to kind of make sure that you're doing it, and you're often graded on almost everything. Whereas in high school, you'll find that there's a lot of things that we do that don't necessarily have a mark associated with it. So on the one hand, you might think to yourself, oh, sweet. Well, I mean, if there's no mark, I'm just not going to do it. That's not always a good idea. And the reason behind that is because in high school and post-secondary and beyond, most of your grade is actually tied to, several key things. And we do all sorts of activities and practice to get you ready and prepared for those sorts of things. So in the same way that I talked about in this class, I don't give a lot of traditional homework. A better word, and I didn't come up with the term, but a better term would be home study, right? I will provide you the tools and the resources and the expectations, and it's your responsibility to balance your time outside of school to ensure that you're using those tools to make sure you're where you need to be. And I want to be clear as well. That doesn't mean that once I've talked about something once, I'm going to say, that's it, I'm done. That was your chance. Obviously, I'm going to be here to support and help you through it. But what we don't want to have happen is that as we work through an entire unit, we don't want to get to the wrap up at the end of the unit and for someone to say, oh, well, I don't have any notes. I say, well, how come? Well, because they weren't for marks, so I didn't do them. So now I don't really feel ready, right? We're trying to avoid that kind of situation. So I thought it's good to make that kind of public service announcement. As we kick off this second unit, this introduction to physical geography, we're going to be talking all about the Earth. We're going to be talking about natural processes, climate, weather, landform regions. So let's get started. When we are talking about weather and climate, it's incredibly important that we talk about the difference. Weather, if you wanted to define it, is the day by day, minute by minute condition of the atmosphere. That is weather. Weather changes dramatically. And actually more dramatically in different areas. Especially I know there are regions out east, on the east coast of Canada, as we're going to be talking about it, what's known as the Appalachians landform region, which has what we call a maritime climate. And the old saying goes out there that nice weather we're having. Someone will say, yeah, well, wait 5 minutes, because it's amazing how quickly the conditions of the atmosphere locally can change. Some of the terms that we would use when we're talking about weather, if you're thinking about a weather report, is it sunny, right? Is it rainy? Is it overcast? Looking at things like humidity and temperature, wind speed, those sorts of things, the day by day, minute by minute conditions of the atmosphere, that is weather. Climate, on the other hand, is long-term. It is an average. For example, if you were to ask me, Mr. Seidenberg, do you know what the weather is going to be like on, Valentine's Day 2021? I can't answer you with absolute certainty as to what the actual daily weather is going to be. I don't know if it's going to be overcast. I don't know if it's going to be sunny. but I can, with a certain degree of confidence, give you a general idea of what you might be able to expect, in Canada, in Southern Ontario, in February, right? In what we would call the dead of winter. So I don't know the exact temperature or the cloud cover, wind speed, visibility, those sorts of things. But my understanding of climate would be able to tell you that, well, more than likely you are going to be expecting, temperatures in the minus, because it's going to be, the middle of winter in a region of the world where you can expect to get cold winters. So climate is all about averages over time, whereas weather is day to day. And again, this slide just makes mention of that. You see the first over here, and I hope you can see my my cursor sort of hopping around here. If you watch the news at night, which sometimes I don't even recommend, because that can be depressing and create fear, and it may actually be better, for your own well-being and mental health, just to sometimes say no. I know that used to sometimes be homework that I would give, hey, watch the news. Sometimes now my homework is, you know what, don't watch the news. But often if you were to turn it on and, see the weather person out there saying, it's a beautiful day here in so-and-so, and then let's look at the weather. And there's actually all sorts of really great YouTube fail videos and whatnot too, of like news bloopers. A lot of really good ones actually involve meteorologists and weather personalities, because sometimes in working with the green screen, which allows them to sort of project, the country. There's all sorts of sometimes like wardrobe issues or, technical difficulties. News bloopers can be pretty funny, especially because the people aren't trying to be funny, right? They're trying to be really serious, and sometimes they run into some issues. But this would be something that you would expect to see on, kind of a daily weather report. And we live in a day and age where getting the weather is as easy as asking, hey Siri, or okay Google. And again, I apologize if I just set off some of your devices. There are numerous apps, and many of them, free apps that will tell you, hey, what is it that you want to know in regards to weather. This one down here, climate, long-term weather patterns of a particular place or region. And again, that term region showed up in our 5 themes of geography, presentation at the very beginning of the semester. When we think of region is about dividing up areas based on kind of similarities and differences. And if you have a region or you have an area that is noticeably different than another area, well, then maybe you might draw a line and say, on this side of the line, you could kind of expect the following, whereas if you're over here, you may be experiencing something different. And I know you can't really see it too well in this particular, the size of this picture over here, but this is actually divided up into different climate regions. And you'll actually notice that the climate regions, they don't necessarily care about provincial boundaries, right? You can actually see the provincial boundaries that have been drawn. There's Saskatchewan, where they don't do daylight savings, Alberta, BC. But where you see these other kind of color-coded lines, they don't always perfectly follow these national or provincial boundary lines. And part of the big reason for that is nature doesn't really care where you draw your national border, right? That's actually something that we're going to be talking about later. It's hard to sort of draw a fine line between naturally occurring climate regions because it is sort of a gradual change. So, good news for you, you do not have to try to decipher or memorize this, because if you were to ask me, Mr. Seidenberg, can you interpret this? No, not really. I'll actually leave that to the experts. But if you've ever wondered how they try to decipher what it is that they're looking at, that's where a lot of the science is involved, in knowing what to look for and how to interpret it. You know, temperature, precipitation, you know, how do they come up with the likelihood of knowing whether or not it's going to rain? You know, the way that the wind is coming, how do you predict that sort of thing? You know, what is atmospheric pressure? You know, are you telling me that air actually has like mass? And again, this will bring you back to your science classes. This is kind of what the rest of the day we are going to be talking about. Factors affecting climate. And I actually like that they're in this order, L-O-W-E-R-N, Lowern. So if I were to, just annotate the factors affecting climate, Lowern, that will help you as a mental trick for on your next unit test, when I will ask you about this, and we'll look at, you know, being able to identify and explain how each of these factors affect climate. That's a good, as we call it, mnemonic device for remembering latitude, ocean currents, winds and air masses, elevation, relief, and nearness to water. Begin with Lowern. I know it's not a real word, but there you go.
Can you just go back on the other slide for a sec, please?
On this one?
No, the one you just showed us.
This one?
Yes.
Sure. And again, I'll also post this for you. So not only will you have the handout guide, you will also have the PowerPoint. You can have it.
Okay, I'm good now. Thank you.
No worries. So we are going to be unpacking this. Now, I have good news for you. You know, it says Canada has 8 major climate regions, and you're like, oh no, man, I just memorized the provinces and territories. Do I have to memorize the climate regions? No, you do not. Okay? You don't. I'm not going to make you memorize the names of the climate regions. What you will find is that when you become more well-versed in understanding how Lowern affects climate, it enables you to think critically about different regions of the country and, you know, make predictions as to what you could kind of expect in those different areas. And there's some general, you'll see as we go, there's some general expectations I would have of you understanding the difference between, as we'll talk about, for example, a continental climate versus a maritime climate. That sort of thing I do care about, but do not worry about, hey, there's a typo here. Oh wait, no, there's not. Whoa, that's weird. You know, sometimes you look at a word and it looks wrong. That ever happened to you? Happens to me sometimes. So you see them here again: Arctic, taiga, Cordilleran, and we'll talk about this when we actually also superimpose landform regions, which is something that I care about. But if you see where they've drawn these lines, each of these regions of Canada have quite unique and different climate characteristics. Speeding along for a little bit because this is what I want to talk about now. I want to go in order. Now, let me also say this. Sometimes people say, Mr. Seidenberg, are they in the particular order based on most important to least important? No. No, they are not. Different areas of the world will have different climates, and different factors of the 6 that are listed here will be more or less important depending on where you are. If that sounds a little bit vague, it will become a little bit more clear as we try to make sense of what they are and what they mean. Sometimes the absence of something can also have an impact. For example, the last one where it talks about nearness to water. Water has an incredible impact on an area's climate. And so the opposite is also true. If you are not near a large body of water, well, that will impact you. So the L stands for latitude. I like to start with this one, especially because you should not be a stranger to this term. We talked about this in our last unit, right? How far are you from the equator? This is also when we talked about an introduction to the idea of seasons and the Tropic of Capricorn, the Tropic of Cancer, what that means for us. I'll write this in as sort of a general annotation. Come on, text. Generally speaking, the further you are from the, oh man, this is gonna, you are from the equator, the colder on average it will be. We need to be careful with this though, okay? Because there is some truth to this statement, but there is more than one factor that affects climate. Sometimes people take this to the extreme, right? They just look at latitude and that's all they look at. And they're like, oh, you have a high latitude, it must be cold. Well, we have to also understand it doesn't mean that it's cold all the time. And there are actually many areas on our planet right now that have a further northern latitude than we do in southern Ontario, and yet don't have as cold winters. And a really classic example of that actually would be looking at the UK, looking at, Great Britain and the UK. They are further north than we are. I know we often think of Canada as we the north, but where we live in southern Ontario is actually further south. It's closer to the equator than the UK. And yet if we think about winters, there's definitely a lot of stereotypes in regards to Canadian winters being a lot worse than winters in the UK. So why is that? Again, not any one of the factors that affect climate. You don't want to look at just one. You want to look at them all together, put together the pieces and then kind of make your calculation. But again, a general concept in regards to latitude, the further you get from the equator, the colder on average it is going to be. Easiest way to think about that, where are the coldest regions of the world? Well, the North Pole and the South Pole, right? They experience something called permafrost, and it's because they are the furthest away from the equator. They don't get any direct sunlight. So there you go. Clear my drawings, move on to the next one. Does anybody have any questions on how latitude impacts climate before we move on to the next one? Remember, longitude matters for time zones, latitude matters for climate. Moving on to the next one. Ocean currents. Again, oh boy, do we need to memorize the names of, no, you do not. Now, if you want to become a marine biologist or you want to get into oceanography, or deadliest catch or any of that sort of stuff, well then maybe you could do some additional work and study. But for grade 9 geography, fear not, friends, there are no expectations that I have in regards to you memorizing ocean currents. I do, however, want you to understand conceptually, the oceans do not sit still. I know sometimes we think of the ocean like a pool or like a bathtub, right? In a pool or in a bathtub, the water is just sort of stationary, right? It's just sort of sitting there, right? In the tub, in the pool, it's just there. Sometimes we can visualize oceans in the same way. We just think, well, it's just kind of like a big bathtub. It's kind of like a big pool. There's just a bunch of water. What we often don't realize, unless we have the right tools to kind of visualize it, there are Well, again, this is where, how many of you, show of hands, how many ever saw Finding Nemo? Some of you, I actually can't see you right now. Hopefully you're putting your hands up. Hopefully that was maybe a movie you grew up with. And this is where you talk about things like the Gulf Stream and, you know, these underwater highways, I guess you could say, movement of water. And that's not fiction, that's real. There are underwater highways, movement of water all throughout the oceans in the world. And incredible, immense amounts of water moving all over the place. And a lot of it actually has to do with the fact that the sun warms the water closest to the equator, and those warm ocean waters move around based on the concept of convection, right? Anybody here can tell me what convection is, remembering from your science classes? Nobody wants to say anything, I know. I get it. It's
I
Friday.
don't remember.
Maybe if I do some actions like this, convection. Sort of
Like rain going into clouds.
So what you're describing there a little bit is part of what we call the water cycle, and that's something that plays a big part in our understanding of how all this is put together too, right? The idea of evaporation, condensation, precipitation. You're like, oh yeah, okay, I remember this stuff for sure. That is a thing. But what is convection or convection currents? Maybe that will help you.
I have an idea. I think it's like, because when you're out at sea, like the water's usually like warmer. So when you get near shore, it starts to get colder, and then the water will rise.
Yeah,
like when maybe the water's cold, it'll rise.
So yeah, the reason why you have the movement within the water and also within the air, and by the way, when we talk about convection, we're going to be talking about it through air, water, and also beneath us, beneath the surface of the earth, into the mantle of the earth when we review our understanding of plate tectonics and stuff like earthquakes. The concept of convection is that heat rises, cool falls. That's the concept of convection. As water or air warms up, it begins to rise. And then as it begins to rise, it begins to cool. And as it begins to cool, it gets forced down by the warm air that is rising to replace it. And this is actually where we begin to get the idea of, if you've ever wondered, like, yeah, how do we get wind? Wind is a result of convection. It's that idea of the energy from the sun that warms the water or warms the air, causes the pressure of it to change, causes it to rise. As it begins to rise, it then begins to cool. As it begins to cool, it then begins to be forced back down as it's replaced by new warm air that is rising. The cycle continues. So this is happening in our oceans. Now, what I'm going to be doing now, before we get to winds and air masses, no, you know what? I'm going to give you, and by the way, because this is the remote class, we have a little bit of flexibility of when we want to do the breaks. So I'm going to give you, kind of a 2 to 3, no, let's make it 3. I'm going to give you a 3-minute kind of stretch and get a drink break. If you're worried and you're like, wait a minute, what about our 15 minutes? Don't worry, right? We are going to spread it out over time, make sure that we can refocus ourselves. It gets long staring at a screen all day. So the clock on my computer says that it is 1:34. So let us return at 1:37. So you have 3 minutes, which is 180 seconds to go get a drink or stretch. I'll pause the recording. Don't leave the class, because then I have to send you back in. Don't leave the meeting, but you can step away from your computer. So I've resumed the recording. And I didn't record while we were watching the YouTube video that I posted in Edsby that helps to make sense of understanding how Ocean currents, things that we don't really see, especially where we live, we don't live near the ocean, have an incredible impact on the global climate. And one of the things that I liked that it mentioned was that all of these climate factors are interconnected. That's why it is so complex and challenging to try to accurately determine, well, if this happened, what would the impact be? Well, it's hard to say because there are so many other things that might be impacted, right? It's not quite so simple. So again, don't worry about memorizing, ocean currents and all that sort of thing. Just understand that, again, the superheated water around the equator region is moved throughout the earth like a heat pump, and the warm water, as it travels, is going to have an impact in the areas in which it travels to. And so if anybody has ever been to the UK, especially in England and London. In fact, there used to be a company that made clothes called London Fog. I don't know if they still make stuff. They used to make a lot of trench coats and stuff like that and other men's apparel. That term, London Fog, London, especially in England and other areas of the UK, are renowned for having, a lot of fog. And one of the big reasons for that is because of the impact of different currents meeting each other. Warm currents in the Gulf Stream meeting with cooler currents of, the North Atlantic. The mixing of that water can have a dramatic impact on the local area. And by the way, you don't have to go to the UK to experience that. In areas of Canada as well, especially on the East Coast, if you live near the shore of places, like Halifax or PEI or New Brunswick or Newfoundland, you are well versed in, what fog is as well. Moving above the surface, we're not directly talking about ocean currents right now, but again, we can't ignore them because ocean currents affect winds and air masses as well. And again, you do not need to memorize these. Okay, an MP, CP, MT. Oh boy, how do these all? It's actually the same kind of concept of convection that we talked about in our last section. Can somebody review for me what I just told you earlier? What is the concept of convection?
It's when heat rises and cool falls.
Exactly.
It is? Okay.
That's exactly what it is. And what makes this next section that we talk about easier is that that same principle that we saw in the video with ocean currents also applies to air masses all over our planet. I know often when we think of air, and sometimes we talk about things like air pressure and humidity, and if people talk about air having a weight, that's something that we kind of roll our eyes and be like, well, how come I can't feel it? Like, look, oh, I'm raising air, I guess. I mean, air has no weight. It does. And the thing is that just like how if we look at the ocean, and the ocean is, well, obviously the ocean is alive with ocean creatures, and I know water's not alive, but the ocean is full of movement that we don't see. The same thing is very true in the winds and air masses around our planet. The fact that the Earth is spinning on its axis, and of course is tilted, means that as air rises and as the Earth continues to move, this is kind of where we get winds from, because the warm air near the surface will again begin to rise, but then as it rises, as it moves, it cools. It also interacts with other masses of air that take on characteristics of where they happen to be from. And this is actually a really good connection back to latitude, because what was the general principle of latitude that we talked about earlier today? What would you say was a general principle of latitude when we talk about climate? ribbit. Do I have to go back there? Fine, I'll go back there. Remember, I even typed it up. What do we say is the impact that latitude has on climate? What was a general principle that is true?
That the further you are away from the equator, the colder it will be, like averagely, though.
Yeah, exactly. And that is, by and large, generally speaking, that's true. Okay, there's more to it than that, but that is something that you can tell a lot about. You can make a lot of predictions about an area's climate based on their latitude. So if somebody told me that they were from a place or the latitude was, 66.5 degrees, oh my word, that's the Arctic Circle. So I can already make some predictions about what it might be like because of the latitude. The same thing is true if we're looking at where these different winds and air masses are coming from. What do you notice about all these blue ones that say that they're cold, right? Polar. Where are they coming from?
North.
Yeah, they're coming from the north. They're making their way down. What about all these, red ones that are supposed to, represent warmth? Where are they coming from?
The south.
Yeah, coming from the equator. Now, we know, of course, that if we were looking at the southern hemisphere, that would be reversed, right? Because if it was coming from the South Pole, you would see them moving north. But again, they'd be moving, the cold is moving towards the equator, the warm is moving away from the equator. It's this interaction and movement of these different air masses that gives us wind. And there are some somewhat predictable types of wind that we can experience, but you also sometimes hear about, again, this is when we talk about the difference between weather and climate. Sometimes you get like a free heat wave or a cold snap. Sometimes I know they love talking about it on the news, the concept of the polar vortex, right? Which sounds quite ominous when there's just a particularly large, cold air mass that may be making its way, further south. And again, these are not sentient. What I mean by that is they don't have a mind of their own, right? These are not creatures that are deciding, hey, I'm going out for a hike. These are large, massive, in some cases, continent-sized parcels of air that interact with other parcels of air, and their movement throughout the world gives us a lot of different climates. This is why some areas also get a lot of rain in areas, because if there's a lot of warm, moist air that's making its way towards the coast, well, then guess what? It's going to bring a lot of humidity. It's going to bring a lot of water with it. There's also a lot of areas that don't get a lot of rain because most of the winds and air masses that they experience are what you call continental, in the sense that there's not actually a lot of moisture in the air. And if there isn't a lot of moisture in the air, well, then you're not going to get a lot of rain. The next one in our journey of Lowern. Actually, you know what I'm going to do for you, because there's a lot of talking on my part. And as promised, I want to make sure that we do not just stare at a screen nonstop. I'm going to give you your 15 minutes. Yeah, your scheduled 15 minutes. It is now 2 o'clock according to the clock on my computer. So you have a 15-minute break. We'll come back and we'll do the rest. I would suggest don't look at your phones, right? Just take an eye break if you need to. Walk around, get a drink, stretch. I'm going to do all of those things. I'm also going to record. I'm going to pause the recording. So, going back to air and air pressure, it's kind of a fascinating thing and this also is kind of connected to to convection to some degree. We talked about earlier the idea of convection being heat rises, cool falls. That is convection. Heat rises, cool falls. What this also winds up meaning is that, and this goes back to topographic maps from our last unit. Remember, we were talking about changes in elevation. We know the surface of the earth is not flat. It is extremely varied, right? We have very, very tall mountains, and we have valleys and plains and all that sort of stuff. Sea level is kind of the zero mark, right? If we talk about zero, zero for all intents and purposes for us, how do we measure all this sort of thing? We use zero as sea level. Okay, that's sort of the indication of a place's elevation. In keeping with convection and heat rising and cool falling, as air rises, it begins to cool. So the same principle applies for if you are an area of land that has a high elevation. You'll find as you rise, and again, this is, you know, if you look at the legend over here, thousands of feet, and again, they're using, it's an imperial on this side, it's meters on this side. So this is a big difference, you know, 4,000 meters, well, that's 4 kilometers, okay? So from sea level to 4 kilometers, that's a big difference. As you rise, the air actually begins to thin, okay? It changes its air pressure and its ability to hold on to heat. And that is actually why especially if you look out into the distance and you can see, you know, the mountains. If you were standing in parts of Alberta and you were looking at the Rockies, in many cases, you would see what they call snow-capped peaks, right? The tops of mountains being covered in snow. Well, part of the reason for that is because with certain mountains, if their elevation is high enough, it means that the temperature at the tops of those mountains remains cold and sometimes permafrost, you know, indefinitely throughout the year. This is actually one of the reasons too why with airplanes, certain airplanes that fly, you know, very high in the air have to be pressurized. They have to have what's called a pressurized cabin because they're flying where the air is very, very thin, which means there's not a lot of oxygen in the air, and it's also very, very cold. So sometimes if there is a flight emergency with, you know, a big plane that's flying very high in the sky, and not all planes fly at the same height, by the way. But if you have a pressurized cabin that is flying very high and all of a sudden there's an issue where there's what we call cabin depressurization, and, you know, the oxygen masks begin to fall. The reason why the oxygen masks are falling is because up really high in elevation, again, as I said before, the air is actually thinner at the molecular level, which means the richness of the oxygen in the air is not high enough. So I know it's weird to think about, but it's like you could breathe all you want. It doesn't matter how fast you breathe. If the air is too thin and there's not actually enough oxygen in the air, you could suffocate even though you're breathing in and out rapidly. Just because you're breathing fast doesn't mean your body is taking in oxygen. So again, I'm not trying to scare you with it, that where we are now, this does not affect us where we live in our topography, the Great Lakes, St. Lawrence lowlands. You know, don't worry. It's also not like if you climb like the Niagara Escarpment, you know, or Mount Nemo or anything that's in this area, you know, don't worry about, oh my goodness, is the air going to be too thin? No, we're talking about, you know, massive changes in elevation. Especially stuff like, you can see documentaries if you want to look at stuff like Mount Everest, right? One of the reasons why climbing Mount Everest is such a feat is because your body actually has to train in order to do it. Mount Everest is so tall and the air is so thin that your body has to actually go through a process called acclimatization, where your body has to get used to the fact that there's less oxygen in the air. And that actually takes some time. That's why people can, if they're not careful, they can start getting lightheaded and dizzy, and they can pass out, and they can require oxygen masks. Anyway, there's some fun trivia for you. But if we're looking at the different climate of different areas, you know, across the world, elevation does play a role. If you are a low-lying area that is not all that high above sea level, you'll find that on average, your temperature is going to be warmer. And the reason for that, again, is because the air is able to be more dense and hang on to, the heat. Whereas as you begin to move up the sides of mountains, you can see even the types of plants that you're going to see will also change. And eventually you'll get to the point where there are no plants or trees anymore if you go high enough up. This brings us to our next one, which is relief. Now, this is kind of an interesting one because this is where we combine a lot of what we've talked about already. We're going to be looking at winds and air masses. We're going to be looking at ocean currents. We're also going to be looking at elevation. So if you combine those three things together, it helps to explain this concept that is known as relief. And I'm actually going to try to annotate this a little bit, because I usually draw this on the board. It's kind of a funny way to think about it, but I find sometimes it helps. So I'm going to personalize this mountain and make it a character. We're going to say this mountain is alive. We're also going to pretend that this cloud is alive. There they go. So there's the mountain and there's the cloud. You might think they're friends. That's where you'd be wrong. Dun, dun, dun. What begins to happen as warm, moist air makes its way off of the ocean as it is moving, throughout, because of different, the way that the air is moving, as we've talked about earlier. Sometimes what will happen is that a big parcel of air will run into massive changes in elevation, right? As the wind is taking all of this through the water cycle, evaporation, condensation, as the cloud is making its way across the surface, it comes to a rapid change in elevation, like a mountain. Well, what winds up happening is that the wind's got to go somewhere, right? It can't go through the mountain or through the mountain chain. So where else does it have to go? It goes up. It gets forced up and over the mountain. Well, this is where kind of the fact when I talked about them not being friends, I'm going to pretend that this mountain is a bully, right? We're going to pretend that this mountain doesn't really like this cloud. And as the cloud is making its way over, it's kind of like the mountain sucker punches the cloud, so to speak. If the cloud was coming by, oh, hey, mountain, how's it going? And then the mountain's like, give me your lunch money. And it socks it in the gut. I know it's a little bit violent. But if you had just eaten and somebody punched you really hard in the gut, what might probably happen? What would be a physiological...
You're gonna throw up.
Yeah, probably everywhere. You're gonna spew everywhere, especially if you just had like a big drink or you just ate a bunch. You're like, oh my goodness, I just ate a mandarin. I'm so full. If somebody came over to you and said, ha, bam, and punched you right in the stomach, look, it's all coming out. That's gross. I know. You're like, where is he going with this? This is why we have something called rain shadows. Because as this cloud, full of moisture, right? It just had a big drink from the ocean. It's so full as it's making its way towards the mountain and the mountain punches it in the gut. I've got to draw some more. So it's like, oh no, like, oh, that feels terrible. Blah. And it's gonna throw up all over the side of the mountain, right? See, that's the rain over there. It's violent, I know. But then as that air mass makes its way up and over, you'll notice there's no more moisture in this air mass. Why? Because it left it all on this side of the mountain. That's relief, friends. And this is actually, we experience this in Canada a lot. If you look at one of the rainiest places in Canada and you look at one of the driest places in Canada, they're actually fairly close together. one of the rainiest places in Canada is the city of Vancouver. In fact, the entire west coast, where the Pacific Ocean meets the shore, the coast of British Columbia. It gets an incredible amount of precipitation. Part of the reason for that is because it looks like this. As these clouds make their way inland from the ocean, as they rise up the coastal mountains, they lose all of their moisture. It's too much for them to hold. You know, by the time they get up and over the mountain, they've lost all of their moisture. So by the time that it gets over the mountains and makes its way inland towards Alberta and into Saskatchewan, it's got no water left to give. And if you actually look at, and we're going to be talking about this in our next class, if you look at what we call climate graphs that measure, you know, temperature and precipitation in different provinces and in different areas, you'll see that Vancouver gets an incredible amount of precipitation all throughout the year, whereas places like Calgary and Edmonton and, you know, Regina actually hardly get any at all. Even though they are, you know, not all that far apart. I mean, I realize we're talking in some cases like thousands of kilometers, but this is the principle of relief that we see happening on the West Coast. And it's the same actual principle looking at the difference between, you know, the coast of areas in California and then moving inland, you know, towards places like Nevada or Arizona. I know that California, in Southern California, does have challenges when it comes to, you know, water, and, you know, you hear about droughts and all that sort of thing. But near the coast of California, it actually gets a lot more rain than it does as you move over the Rockies into places like New Mexico and Arizona and Nevada. Those areas are much more desert-like for actually the same type of reason as we've just described here. Let's clear all those drawings. And finally, the last one, which again, you might think I'm repeating myself because you're like, I thought we already did oceans. In fact, because that's what we'd be looking at out here, right? There's a lighthouse and this is on the East Coast. We're looking at the ocean. I just know from the picture, this actually happens to be the Atlantic Ocean. Like, we already did this. Why do we have to mention it twice? And I will tell you, because there is more water than just oceans in this world. Okay, in fact, there are all sorts of lakes, some big, some small. We actually happen to live by some great ones. And I use that term on purpose because we call them the Great Lakes because they're the biggest in the world. You don't need to be near an ocean to have your climate impacted by what we call nearness to water. This again goes back to science. If we talk about the density of, you know, air versus a liquid versus a solid, okay? The molecules in air are very spread out, whereas the molecules in water are much closer together. And when it comes to heat and temperature and retaining temperature, one of the things and you can actually do an experiment with this at home if you want. It's like the difference between you boiling water on a stove or you using a hairdryer. Question for you. Anybody who's ever used a hairdryer before? When you turn on a hairdryer, assuming it's working properly, how long do you have to wait before the air is warm? Kind of a trick question.
Couple seconds.
Yeah, it's almost instantaneous, right? That's how it works. Like you turn it on, and again, I'm not getting into the mechanical nature of how it heats the air and the heater coil and, you know, talking about all that complexity. All I mean is it's actually very easy to heat and cool air. It's actually quite rapid, right? You turn on the hair dryer and the hair that comes out of it is instantly warm. You know, you use it to warm your hair. But after you turn the hair dryer off, how long does it take before the air kind of makes its way back to somewhat of a regular temperature?
$19 seconds.
Okay, I have never timed it. That's possible. But yeah, my general point is the minute that you turn off the heater coil, the air is going to cool down, right? In fact, well, I know my wife has one of these because I guess for styling and whatnot, because she's a licensed hairdresser. Some hair dryers actually have like a cool button on them where you can push the button and it causes the air to still move, but it actually turns off the heater coil. And again, don't ask me what the benefit of that actually is. I don't really use hair dryers very often. As you can tell, I got like a really bad cowlick going on here. But that's besides the point. Air heats and cools very quickly. Water, on the other hand, does not. Water takes some time. How many of you have ever made tea or made craft dinner before, or soup, or something that required you to boil water? Anybody here ever boiled water before? I can't see hands, so I'm assuming some put hands up. Yeah. When you're really hungry and you're trying to make craft dinner, doesn't it seem like it takes forever for the water to boil? You're just staring at it. You're like, come on, like get going. You turn on the stove and you wait, and it seems to take forever. It eventually gets there, but yeah, it seems to take some time. It takes a lot longer than just heating up the air. But here's the thing. Once you turned off the stove, let's say you got water up to boiling, you turned off the stove, maybe you waited a minute. And by the way, I don't recommend this. I want to make this very clear in this recording. I am not saying for you to try this. Do not try this at home. What would happen if 1 minute after, or 19 seconds after boiling water, you decided, yeah, you know what? I'm going to stick my hand in that pot. What would happen?
Well, the water would probably be like pretty hot. I don't know.
Oh,
So
yeah.
you would burn your whole hand, and it wouldn't be very pleasant.
Yeah, that's exactly what's going to happen. Okay, although the water takes longer to heat up, it also takes longer for it to cool down. That's kind of the point I'm trying to make here. And we will connect this to geography, right? Again, if you make yourself a cup of tea or you're boiling some water, you pour that boiling water into the mug, and you better be careful not to just chug it back, because it is going to take some time for it to cool down, right? It's not instant. It takes time. It will cool down eventually, but it's a much slower process. This principle applies when we are looking at the impact of nearness to water and climate. Because air and water lose and gain heat at different speeds, being near a large body of water can help to what we call regulate the temperature of a region. It can actually stop the temperature from having massive extremes, from going like super hot and super cold. It actually helps to kind of keep it at a more even and constant temperature. Not the same all the time, but it stops it from having crazy extremes. This is actually something that, again, can sometimes, when you think of, I'll just put it out there. When you think of the desert, okay, like the cartoons and everything, when you think of the desert, what do you think of?
No water.
Very true. That's actually a really scientifically valid point. That is actually what makes a desert, right? Whether or not it gets a certain amount of water, that's how we measure it. So yes, very little to no water. Absolutely. What else do you think of the stereotypical characteristics of the desert?
I think of it as very hot and like very dry.
Yes. Also, yes. Here's the thing. You're 100% correct, but you're only 100% correct for part of the time. And what I mean by that is when we picture the desert, we're usually picturing it like in the cartoons during the day, right? During the heat of the sun, as the sun is just baking the landscape, and you think of, sand that would burn your feet. It's dry. You can, see the air because of the heat waves. You're 100% correct. What we often don't think about is the deserts at nighttime. believe it or not, there's actually a lot of people who need to be hospitalized, not because of heat stroke, but because they go into a desert and they're there when the sun goes down, and then they weren't prepared for the fact that once that sun goes down, the desert gets cold real quick. True story. I'm not making this stuff up. That's one of the things that makes deserts so difficult to live in, and why, you know, the types of vegetation and the types of creatures that live there, you know, have to be, you know, pretty tough in order to adapt, because you get super hot during the day, but you also get really, really cold during the night. The reason for that is because there's no water. And that lack of water means that there's no regulation of the temperature. So you get extreme hot, extreme cold. Here's kind of an interesting thing that maybe some of you have done, and it will help to kind of prove the point here a little bit too, the effect that water can have. How many of you have ever gone swimming in a pool during the day, during the summer? Everybody probably has at some point in time. Don't overthink it, but let me ask you this. Why do you jump in the pool during the heat of the day? What are you trying to achieve? I know it sounds like a weird way to put it. Sorry, what? Yeah, to cool off, right? It's hot outside. Why does the water feel so nice? The water feels so nice because the temperature of the water is cooler than the temperature of the air, right? If the air outside, especially during July, is like 40 degrees Celsius, well then jumping into that water that's maybe, you know, 20 degrees Celsius or 25 degrees Celsius is going to feel amazing. It's going to feel cool and refreshing because the water is cooler than the air. So that's why we swim during the day. How many of you have ever gone swimming at night? Again, I can't see your hands. I'm assuming some of you have. What is so incredibly different about swimming at night? Sometimes you jump in the water and then you climb out of the water. And then why do you feel the urge to jump right back into the water?
Because the air is cold.
Yeah, it's a weird thing, right? If you've never experienced it, night swimming is so different than swimming during the day, because once you jump in the pool and you get out, all of a sudden you're like, oh, it's so cold out here. You jump in the pool to warm up. The water feels warm. It's actually kind of a cool thing. What's interesting is that that same pool, you may have swam in it 2 times that day. You may have swam at noon when the sun was, you know, high in the sky and been refreshed because the pool felt nice and cool. But you may have jumped in at midnight and enjoy being in the water because it feels warm. The temperature of the pool didn't change. It was the outside air, that relative air difference. That's what makes it feel like such a different experience. Yeah, sorry. Well, I thought somebody had a question. When we're talking about the impact that water has on a climate, and we'll continue to talk about this in our conversation, you know, next week, once we meet again. It's not just the ocean and the ocean currents that impact the climate of an area. Okay, if you actually look where we are in, you know, it's famously known as the Great Lakes St. Lawrence lowlands, we actually have our climate impacted dramatically by the Great Lakes. You know, Lake Ontario, Lake Erie, they really do impact what our weather and climate are like during the year. If we didn't have those large bodies of water, our climate would be very, very different. So they're not true ocean currents, but still being close to water, especially coastal regions and areas where there's lots of lakes, lots of rivers, it can have the effect of helping to regulate the temperature so it isn't as extreme. Okay, what I'm actually going to do now, I'm probably going to stop the recording portion because I am going to showcase for you a couple of other YouTube clips that are some sort of extension things that we're going to look at in regards to kind of neat and unique climate areas in the world I'm going to actually take you to a place called Death Valley. And this is one of the most extreme climate regions in the world because it's below sea level, but it's not underwater. So it's kind of like, well, that's weird because I thought we said that sea level was where the water is. So how can you be below sea level but not underwater? Again, topography and the way that the land is carved out, that will help explain it. But when we look at things again, like air and ocean currents and relief and all these things together, it will show how it can have such a dramatic impact on different areas. And so we're going to do that. I'm not going to record me showing those YouTube videos, but I will also post it for the benefit of anyone who didn't have a chance to be here. But this sums up kind of the PowerPoint portion of the show. And I will be posting this as well as the PowerPoint into Edsby so that you can have it. So I'm going to stop the recording right now.